Hello, thank you for joining me. This is the sixth demo where we will program the ball shooting sections of our ball shooting simulator. I want to start off by copying and pasting a new demo folder and calling this demo 6. And we'll start using our demo 6 folder. We're going to open our RoboRio. Now, some things that you may notice is that we have a lot of this previous demo code from previous demos, and it's due to the copying pasting that we're doing here. So we have files like this LV, LPS, and the alias. These are files that LabVIEW will generate automatically every time you open a project, and it saves values in there that it needs to remember for building and such. But they're not necessary. We can delete those and clean up our project a little bit. So I'm in Windows and I'm going to just delete everything that's not demo 5. I'm going to hold the shift key and multi-select and hit delete. So I've cleaned up. I'm going to also delete the demo 5 files so that I can rename this demo 6. And then I'm going to open my demo 6 project. Okay, the first thing we're going to do is we're going to review the code. So I'm going to bring up my block diagram, Control E, and we're going to go into our teleop. So here we have our ball shooter code, and there's two network variables here that we need to understand what they're doing. Previously we set it up so that we use our right trigger axis here, and the shooter switch value came in false. Our right trigger would control our ball shooter speed. But let's investigate a little more and figure out what these two variables are and what they're doing in our code. So to do this, we can use our the Finder tool in LabVIEW. So if we go up here to Edit, Find and Replace, we can actually search through our code for different items that we see. So we can either search for objects, which if you're looking for specific functions, you can go through our palette and find the functions that we're looking for, or we can look for text. So in this case we're going to look for text. I'm going to first figure out where the shooter speed is being set and read from. So I'm going to double click in here in my constant. I have to cancel this first. I'm going to hit Control C for copy and Control F. So that was the shortcut to bring up the Finder. And I'm going to highlight in here in the word to search. I'm going to Control V and paste it. So we're looking for shooter speed. And then we can select where we want to look. So we can look at for all VIs that are open in memory, or we can look in the specific VI that's open only in teleop. So we're going to look for all VIs in memory. And if we use our More Options button, we can actually say that we only want to look on the block diagram. So I've unchecked front panel. I don't want to look on the front panel for this. Only the block diagram and only visible items and descriptions. I don't want to find hidden values or hidden things that say shooter. And we'll click OK. We can also do things like case sensitive or match or expressions, but we're just going to look for that because we know That's the exact name we're looking for. And then I'm going to click Find, and it's going to scan throughout my code. This says, do you want me to open password protected VIs? And I'm just going to say no and skip. I only want VIs that are not password. So you see we have 5 items that match where found this text in our code. And we can double click on the item, and LabVIEW will take us there just like it does for errors. And we'll see that's just the label. So that's not what I'm looking for. Let's try the next one. There it is. So you can see here's where we're writing to our network table. That's what that little pencil means. It means writing. And it sets our initial value at 0.7 because we're here in the begin VI is where this is located. So when begin opens, we take this network shared variable, network table variable. We write a 0.7 to shooter speed, and it stores it in our network table. So as you can see, this search window gets hidden sometimes, and it's hard to find. But you can use shortcut keys, Control-G and Control-Shift-G, to move up and down this list without having to find this window. So if I hit Control-G, you see I'm highlighted on number 2. If I hit Control-G, we will go to number 3, and our global variable here, it writes to a terminal on our main to show us what the shooter speed is on our front panel. Also is named shooter speed. I'm going to hit Control-G again to see. We also have a place where we write to a network table variable. That's our speed that we're setting with our trigger. That also is called shooter speed, but joystick shooter speed. And if I hit Control-G again, we come back to the original one that we're looking for here in our teleop. Alright, so let's do the same with shooter switch. And if we look at this code, we'll see that if shooter switch is true, then we're going to use the value stored in the network table. If shooter switch is false, we're going to use the right trigger value from our joystick. So we want to emulate this in the code, but for this demo, I want this shooter switch to be true because I don't want to mess around with the ball speed right now for the demo I want to show. So I want shooter speed to be the thing that sets the motor drives here. So I want this to be true. I want to set this to true when the program starts. So let's look for shooter switch. So I'm going to double click, copy. I'm going to hit Control F for find. That's the shortcut key to bring up the finder. I'm going to hit Control, highlight this area, Control V to paste it. And then I'm going to say all VIs, only the block diagram for my options. They'll stay the same until you change them. And then I'm going to click Find. And I'm going to ignore all password protected videos or VIs. Alright, so I found 3. So I'm going to hit Control G to walk through them. This is just a label. And here's where, in the begin VI, here's where I set it initially. Yours will probably be false. So I want my initial shooter switch network table variable to be true. So that it will use this 0.7 value here at the shooter speed that's also set as a network table variable in begin. And then I'm going to hit Control G again and see where else shooter speed is used. And it's here we'll go back to our original place where shooter switch is used. So if shooter switch comes up true, we will select the shooter speed. That's also, we set it 0.7, and we need to set these as negative so that the ball shooter wheels rotate in the correct direction. Okay, so let's go to the simulator, and I want to show you like where this servo is in the robot and where the ball shooter wheels are as well. And we'll talk a little bit about some other things that we want to do and we can observe. Okay, so let's bring up our driver station and our simulator. Go back to robot main and we're going to start it. And bring up our simulator, and again we can play around with the views. So if I don't hold any keys and I rotate, you can see we can rotate the view. If I hold down the shift key, I can actually zoom in. So I'm going to try to zoom in and show you and if I show you the servo in the robot, and if I hold down my control key, actually will pan us, our camera, and shift key, zoom in, control key, pan, shift key, zoom in. I'm going to actually zoom right into the cross section of the robot here, like so. Right, so I basically cut the robot in half with my camera looking at it, and you see this U-shaped piece right here. This is the ball shooter. This is the servo that puts the ball into the wheels. So here's one of the shooter wheels. The other one is off camera. And this, when I press my green button, this rotates it to 0 degrees and throws a ball into our shooter. So I'm going to open my driver station and enable. And see that very slightly, you can see that the balls are spinning. And if I press my green button, it throws the ball into the shooter. And I'm holding the green button down. Let me bring up the buttons. Here's my green button. You see I'm holding the green button down, and it keeps the servo at 0 degrees. And then when I release it, it brings the servo back to 85 degrees. Okay. And if I push from the last demo, if I push my back button, the agitator will begin sweeping. So we'll keep the balls agitated so that I get balls into my servo. So in investigating this, I see that I can shoot a ball and release it, but my servo runs kind of slow, right? And if I'm sitting here and I'm tapping the button, and say my driver gets overexcited and he's like, shoot a ball, shoot a ball, shoot a ball, and he keeps tapping the button, you'll see that a ball never gets put back into the servo because I never get the servo back to a reset 85-degree position. I need to drive the robot forward and back a little bit to shake the balls up so that kind of like they're getting stuck. Okay, so I have the next ball ready, be in my servo. So I think what I want to do is I'd like to put some timing in here so that when I press the button, I get a rising edge, that I shoot it, put it in the ball shooter for a half second, and then release, have the servo come back and stay for at least 1 second before we're allowed to shoot the ball again. So you can only shoot a ball. We've determined as a team that we only want to shoot the ball every 1.5 seconds. So half a second forward and 1 second back. The other thing I want to make sure of is I don't want to jam up my ball shooter. So unless my wheels have been spinning or are spun up to their speed, I don't want the driver to be able to shoot a ball until I'm pretty sure that these wheels are spinning. Because we could jam a ball into the wheels when they're stationary and possibly jam up our ball shooter. So I want to make sure that everything's spinning up. So I don't have any sensors, unfortunately, on these wheels. So I'm going to use timing. So I want to engage my ball shooter, and then I want to wait a certain amount of time so that I'm pretty sure my ball shooter wheels are spun up before I start injecting balls into the ball shooter. Okay, so we want to start the ball shooter spinning. We want to make sure the balls are spun up. We want to, when the button is pressed, we want to move the servo for a half second and then bring it back for a full second. Alright, so that's kind of what our plan is to make this ball shooter work for us. Okay, so I've drawn up this state machine and kind of want to go through it here. So we have several states, our startup state and our shutdown state, as we normally do. We have an off state where we just want to shut our ball shooter off completely. And we do the actions. We'll create an action called shooter off. And then we'll have a command from a commander, either our teleop or autonomous, and that command will enable or disable or command to shoot. So it's going to have three commands: disable, enable, which will spin up our balls, shooter wheels, or shoot, which will make sure that the spin up is done, and we will throw a ball into the wheels. So if our command is enabled or we've commanded it to shoot, we will go from our off state to our starting spin time. We'll save our starting spin time and we'll turn our shooter on, and then we'll go in here to the spin up state. The spin up state will watch our timer. So if our spin up timer is not complete and command is enabled, or shoot. So if our timer is not complete and we are still enabled, we continue to stay in the spin up speed until that timer is complete, because we want our shooter to be up to speed before we throw a ball in there. If at any time our command goes disable, we call the shooter off action and we go back to off. Once our timer is complete, so our spin timer is complete and our command is still enabled or shoot, we go to the ready to shoot state. The ready to shoot state, if we are only enabled, we stay in the ready to shoot state because we know that our ball shooter wheels are spun up. If command is disabled, we go back to off, we shut the shooter off. But if we get a shoot command, then we activate the servo to shoot, put the ball into the wheels, and then we save the start time for our shoot time. Okay, so this is going to be our half second. So then we are in the fire state and we wait for our shoot time to complete. We wait for that half second that we're going to wait in at 0 degrees. Then when our shoot time is complete, we start another timer, our reset timer. We deactivate the servo, which means we bring the servo back to 85 degrees. Here we're in our reset state is we're going to wait for 1 second to make sure that our servo gets all the way back and hopefully gets a new ball into it. And so we stay in the reset state until the timer is complete. Once the timer is complete, we go back and do into our ready to shoot state. If we go to disable, we go back to shooter off, and then if we enable again, we need to make sure we spin up and get into ready to shoot. So it's important that we always go through the spin up state to make sure that our ball shooter wheels are up to speed before we start throwing balls into them. So this is the state machine I'm going to try and implement in with the architecture, and we'll start coding. Okay, so shutting down my simulator, and I'm going to begin coding. So we want to my projects here open, and we're going to create a new actuator template, calling it shooter. So I'm going to go to our RoboRio code, templates and utilities, system templates, and another actuator template, and we're going to save as and do a copy. So I'm going to we're going to select our template actuator, save as, we're going to make a copy, and we're going to call this shooter, or shooter actuator, and we're going to keep it in our project, and we're going to hit continue. And then we are going to go to our desktop and find our demo 6 folder, and we're going to create a new system, shooter system. So let's create a new folder, call it shooter, and this is we're going to put the new library that we're just copied. We're going to put it here in our current folder, our new shooter folder. Okay, so now in my systems I should have a shooter folder with the shooter actuator library. Alright, we're going to open up our actuator loop. Control E, bring up our block diagram, and then I'm going to copy my block diagram and put it here in my copy my state machine and put it here in my block diagram. So the first thing we want to do is fill in our states and our actions in our different enums, state enum and our action enum. So we're going to right click over here. This is my state, my template state enum. So I'm going to open my type def, and I'm going to right click and enable items, and we're going to fill in each of our states from our state machine. And we're going to size it to so that the biggest one fits. Again, apply changes, save all. Alright, then I'm going to close it, and I'm going to do the same for my action list. So the next thing we want to think about is all the different variables that we're going to have to manipulate. Now we may miss some, we may add too many, or we may forget to add some, but the architecture allows us to keep adding and subtracting items to our main cluster as we discover them or remember that we should have fixed them. Before I do that, you'll see, you'll notice that I get this grayed out section in different places in my code. Remember, the way to fix that is we're going to find those items, we're going to right click, and we're going to review and update. Every time we change a strict type def or whatever and remove names, LabVIEW wants to make sure that the new name fits the old name. So before it was called Action A, and now they're asking what should I replace Action A with, and I'm just going to say replace Action A with no action and approve it, and the same here, and approve it, and then apply changes. And then over here I have a state that needs to be addressed. Review and update. We're going to make idle off. We're going to approve that. And so all my idles, I'm going to, every place where the code used to have an idle, I want that to be replaced by off. And I'm going to apply changes there as well. Alright, now as we think about the variables, let's go through our state machine and see if there's any variables that we need to add to our cluster. So we have the save start spin time. So we have a start timer, and we only need a start timer for each once, and we'll reuse that start timer as we go through each state. But we do need to know what the end time or the time that we're shooting for each of these states is. So for a spin up, we need to have some kind of value that tells us how long do we spin up. So this is this actuator output double. I'm just going to copy this, and I'm going to create 3. So we need a timer for spin up. We need a time to tell me how much time I spend in the fire state and how much time I spend in the reset state. So there's 3 values that I'm going to need to get somehow, either through hard coding as a constant, or we read from variables from our dashboard or global variables that we store. But otherwise, anyways, I need those 3 variables here in my master cluster. Okay, I'm going to set these values as constants for now, but we will have the option later to make them variables from the dashboard or global variables as well. So my spin up time, I think it's going to take me about 3 seconds, 2 seconds maybe to spin up. My fire time, I said I only wanted a half second, and my reset time, I need 1 second. That's my initial values. I may have to come back and change these later as the performance of the robot dictates. So the next thing we want to code is our command actuator global and clusters. So I'm going to open up the command actuator global. Open the front panel here. Okay, let's begin to build our command enum. And if we look up here at our state machine, we have 3 command items currently. We have a disable, an enable, and a shoot. So let's create an enum, call it command, and put it in our library. And we're going to, this is our command actuator cluster, and that's also a type def. And we're going to take this new enum that we created, we're going to drag it inside this cluster. We'll just call this command. It's the shooter, since inside the shooter library. So we're going to, and we don't need a boolean here. And then one other item I think I'm going to need the commander to do is tell me the ball speed or the shooter speed from 0 to 1. And we will file apply changes and file save all. There may be some other items that we add to this later, and we're going to close, and I can delete this now because we have it inside our cluster. So our global now has our command cluster that the commander writes. It's going to write enable, shoot, or disable to the shooter, and it's going to tell it what the shooter speed should be. 0 to 1. 0 to 1 being 100% and 0 being no speed of the wheels. Wheel speed is 0. Okay, so one thing I'm noticing is we didn't give our shooter a template icon. So let's go back to our project, Control-Shift-E, and come up here to our shooter library, and go to Properties, and let's make an icon for our shooter. So edit our icon. Okay, created my icon. Click OK. It asks if we want to apply this icon to all our items in our library. We say yes, and we click OK. And I can close my global here. Save it. So we've completed our command actuator global. Let's name this correctly though. Command actuator shooter data. So we're going to open the front panel, command actuator shooter data for our naming convention here. And we're going to save all, close. And reselect it. And the other global that we need to think about is the data that we send outside of this loop, information that other parallel loops may need to know about the shooter. So over here is our actuator shooter output data. One of those items actually might be the state. So if our commander wants to shoot a ball, it may need to know if the ball shooter is in a state where it can shoot a ball. It may still be spinning up. It may still be moving the actuator or the solenoid, the ball solenoid may be fully extended, or it may not be ready to shoot yet. So let's broadcast in our global variable our current state so that other commanders can see what state the ball shooter is in. All right, so I'm going to open up the actuator template global. All right, and we're going to keep our cycle time. So let's name this shooter cycle time. And let's go get our state from our library. So we're going to select a control. And we are finding our shooter, system shooter. And we want our state. And we are going to place this inside our global as well. And we're going to give it the right name though. Actuator underscore shooter underscore state. We also may want to broadcast our shooter speed. So let's make one of these doubles our shooter speed. And I'll delete this other one for now. So for right now, we're going to send out to the world there's these three things that they can read. They can read our current state, and they can read what our shooter speed is. And I'm going to save this global. So this is the global data that the shooter sets. And over here we want to reselect our cycle time. This one we want to be speed. And we'll get rid of this boolean, doesn't exist anymore. We'll delete that and clean that up. And output, we're going to want to know the speed, actual speed that we're going to set. And this one I'm going to bring up here and select state and unbundle my state off of my cluster. So okay, so the next thing we want to do is let's bring in all our different hardware VIs that make the shooter run. So we will go back to our teleop, which let's go back to our project and open our robot main. And go to teleop where that code is. Down here is our ball shooter code. So I'm going to shrink this so we can kind of drag and drop a little bit. Alright, looks like I have to do two opens. So we got to go to begin, Control Shift E, back to our project and find the begin VI. Alright, and let's copy these. Copy this code here and paste it here temporarily. Alright, I made a constant for this reference, for the drive reference, and a constant for this servo reference. Now, what the programmer, the developer has done is they see that they have two wheels that they got to control, and they know that they can, if they set up a drive, it will automatically set up two motors, and those motors they can control together. So they've decided, because the shooter has two motors, they're going to treat it as a drive. It's really not a drive, but they decided to take advantage of the way that the drive combines multiple motors together. If you remember back in our intake, we created two separate motors, but in this case they decided to use the drive VIs. So we're going to stay with that. I'm going to create constant off of that output, and if you double click on the edge here, it'll shrink it down into an icon, and I need to give it a label. And I'll create one here off the servo, create a constant, and again double click on the border to make it into an icon. So we have a throw reference and a shoot reference, and we're going to add these to our cluster so we can get rid of this placeholder here. And save all. So that gets our opening, or sets up our hardware, or sets up the code to interact with our hardware. And we need to, let's come over here and close. Okay, so in here, this part, we want to actually set our values, and that may be something we haven't added. So let's go to teleop. So they use drive motors, and looks like they set the right and the left speeds the same. So we got to be careful of these negatives and make sure that we're setting them the right direction. and we're also doing a set angle. So I'm going to just drag these two over so I don't have to go find them. And we already have a shooter speed, but I don't have anything to indicate whether I need to set the angle or not set the angle. And I'm not going to set the angle any different than 0 or 85, so I can reuse this code as well. Copy and paste it. And all I need is a shoot or not shoot bit. So let's slide back here and add a shoot or not shoot bit. When that is true, I'm going to tell the servo to go to 0 degrees, and when it's false, I'm going to tell the servo to go to 8 degrees, 85 degrees. Alright, so I'm going to just get rid of this to make some room. We're going to bring in our two references, our throw reference and our servo reference, our shoot reference. Underneath, after I do the shoot reference, I'm going to find my servo speed, or my shooter speed, which I have a variable for, I thought. Guess I do not, so I need to add, I'm going to create a new variable and call it shoot speed. And we want those to be the same. And then we're going to bring in the throw reference, the shoot reference, and I'm going to save and save. Alright, now that we have our variables set and we have our hardware calls set up, we can start to build the logic in our state machine. Okay, I'm going to clean this up. I don't need this to bundle anything into that value. And let's start with our actions. So the first thing I like to do is for the actions is add case for every value. That way I know I have all the values I need to write code for this action. So no action, we're going to leave is no action. Reset time, we're going to leave that. Reset all, we are going to set our shooter speed to 0, and we're going to set our shoot servo to false. So our servo shoot speed is going to be 0, and our shoot servo will be false. The way it will stop any hardware that we're doing and immediately put everything to 0. For shooter off, we're going to do similar. We are going to set our shooter speed to 0 and make sure that our shoot servo is also set to false. And the next action is save start spin time. So we are going to take our current time and we are going to save that to our start time. Now you could, if you wanted to, you could create multiple start times. So we could say a start spin time, a start fire time, and a start reset time, if that made it easier for you to understand. But because we only use start time at the beginning of each state, it's basically just becomes a little more efficient to reuse that start time variable over and over. And that's kind of what we're going to do, because we won't need the start time when we won't need the start time when the start time happened for the spin in the reset state. So we're going to reuse this start time. And so save start time for spin, save it for the shoot time, and save it for the reset time. We'll all do this same thing. We'll take the current time and save it as the start time. So I'm going to take each one of those and I'm going to delete this case and find the other one and delete that case, and then I'm going to duplicate the other code. I'm going to say duplicate code and duplicate code again, and that saved me a little time of having to write it. All right. The next action that says activate shoot servo. Okay, well that means that we're going to set our servo to shoot. So we're going to unbundle by name. Shoot servo. Create a constant and just say true. And the next one is deactivate shoot servo. So this will be the same except it'll be false. So I'm going to again duplicate this. I'm going to delete this case and duplicate this case, and we're going to set the shoot servo to false. Alright, and that's all our actions. All of them doing what we need them to do. So now we can move into our programming our state cases. And like the action, let's add case for every value. Alright, so this is the state. Now we can look at our state machine and we say, okay, here's our off state. What are we looking at? We're looking at the command. The command enable, shoot, or disable all give us routes to take in new states to go to and actions to call when we see those conditions. But so we need to look at our command variable coming in off our global, our actuator input command, and I'm going to get rid of this template code, and then we're going to bring in a case structure. Alright, so when I'm in the off state and my command says enable, I need to save start spin time and turn the shooter on. Alright, now did I have an action for that? I forgot to add shooter on, so let's go back to my actions and over here and add shooter on. Right, and now I need to go add that case to my actions. So there's shooter off. Let's just copy that code, duplicate case, shooter on, and I want my shooter speed to equal the input speed that the commander's sending me. And I'll set my shoot servo to false so it stays out of the way or gets into it, so I know it's in a known position while I'm spinning up. the shooter speed. Okay. So we'll go back to our off state. We say command is enabled. We need to save our start spin time and turn our shooter on. So I'm going to create a constant here, and I'm going to drag it inside the enable. And the next state that I go to will be spin up, according to my state machine. Next state is spin up. And the two actions I need to do, I'm going to create constant here, and then drag it inside. Create constant. Drag it inside. Shooter on, and save spin time, start spin time, and then you can expand that so that you can read it. Alright, so that's the first case. And the next case is disable. I typically like to get rid of defaults when my case structure is an enum, so I always tend to disable or delete the default. So if disable, then we just stay in the off state and we do nothing. So I'm going to create constant here, and we'll come back to off state, and I'm going to create constant and leave it blank, or you can put in a no action, whichever you prefer. Alright, there's two. Let's add case for every value so that we cover every command. And now we should have a shoot command. So if we're in the off state and we're in the shoot, so you can see here it says command equals enable or shoot. So I'm going to delete this case. So the code for enable and shoot are identical, so you can actually add shoot to this case as well. So I can put comma and then start typing shoot, and LabVIEW will fill in the thing that most resembles what is in that enum, and then you can push the arrow keys to fill it in, and we say enable or shoot. For this case, run this code here. Alright, so my off case is complete, and so let's go to spin up. So spin up also looks at command, and it looks at some other things. So let's delete spin up and just reuse this off code, and then we'll modify it as needed. So I'm going to go and delete the spin up code, go back to my off, and duplicate it. Alright, so we're all looking at our command code. So we have two branches off our spin up. My spin up timer is not complete, and command code is equal to enable or shoot. Okay, so there's enable or shoot case, and the other thing we need to look at is the difference between our current time and our start time. So we're bringing our current time and our start time only in this enable or shoot case, and we will subtract them because we want to know how much time has passed. That if I subtract my current time from my start time, this will tell me how much time has passed. Okay, so my enable or command or shoot, which is this case, and my spin timer is not complete. So if my current time, I need my spin time, my spin timer time, spin up time. If this time, the time that's elapsed since I started my spinner, if that time is greater than my spin up time, then my ball shooter is spun up to speed. Alright, so I need another case structure. So I'm going to bring a case structure, and I'm going to wrap this case structure around this code, and I'm going to say if my time elapsed is greater than my spin up. I'm going to actually put the spin up time down here. It makes the wiring look a little bit nicer. If my time elapsed is greater than or equal to, so I'm going to replace this with a greater than or equal, is greater than or equal to the spin up time, then we can go to ready. Ready to shoot, and we do no actions. So I'm going to empty this array. So I'm going to right click on here and I'm going to say data operations empty array. You could delete it and remake a constant too if you wished. Okay, so this means that my time has elapsed. This false means that my time has not elapsed. I'm still spinning up. So we want to come back to this spin up case, create constant, stay in the spin up case, and no actions for this as well. Okay, so that's our spin up case. Now let's go to ready to shoot. And again, ready to shoot is also going to look at, oh, I think the one we didn't do disable, right? We need to do the disable case here. If we get disable case in our spin up, we disable and we go to shooter off. We disable and go to the off state and then go to call the shooter off action. Shooter off and go to the off state. Okay, now we can go to ready to shoot. Looks like we also look at the command enable. We look for shoot and we look for disable. So let's again copy that previous code. So I'm going to delete this case. And we're going to go back to spin up. We're not looking at timers, so maybe I'll go back just to the off and duplicate that one for my ready to shoot. This time enable and shoot do different code, so I need to separate them. And so I've enable and disable, and I'm going to add shoot, so I'm just going to duplicate this case because I'm going to need a state and an action. And let's go through the different states. So at disable, ready to spin, ready to shoot. If disable, I do the same thing. I go to off and I say shooter off. If I go to enable, I stay in the ready to shoot and no action. So I'm going to go data operations, empty array, and I'm come back to ready to shoot. And now if I get a shoot command, I need to activate the shoot servo start time, and I need to save the shoot start time, and I need to activate the shoot servo, and I need to go to the fire state. So we go to fire, we activate shoot servo, and we save shoot time. Start the shoot timer. All right. Now we go on to, let's go into the fire state. So again, we'll go duplicate this one, save us some coding time. We're going to delete the fire, and let's just duplicate the ready to shoot case, duplicate. At fire, we're waiting. Fire one's going to be similar to the timer, so let's copy the timer. Delete this case. Let's duplicate spin up, so that way we have our timers, our current and start time in there. So we're going to right click and say duplicate this case for fire. Fire looks to see, stays in fire until it's complete. And so you can see that fire is no longer looking at the command. It just goes, fires, waits for a time, resets, waits for a time, and comes back to ready to shoot. Then we'll look at command again. So we don't need this outside case anymore. So I'm going to go to the border and I'm going to say remove case structure. And that will remove the case structure and leave anything that's inside code that's already showing. But it'll delete all the other cases, but only leave what was showing, what code was showing. And I'm going to delete this, and we're going to remove element. So in fire, all we care about is looking at our timers. Right? We're looking if the shoot timer is not complete, we stay in the fire state, and when the shoot timer is complete, then we move on to reset. So our current time minus our start time, if it's greater than or equal to our fire time, true, then we run to the reset state, and it tells us when we go to the reset state we need to deactivate our servo, and we need to reset the reset time or start the reset timer. Okay, and if we are not, we continue to stay in the fire state and do no actions. So our reset is going to be very similar to this. So we're going to go to reset, and then we're going to delete this case and duplicate the fire state. Duplicate. This time we're going to use the reset time. Current time minus start time greater than reset time. If that is true, means that we have completed our reset, and we go to ready to shoot and no actions. Data operations, empty array, and false, we stay in the reset state and no actions. And the final states that we need to make sure we got right is the startup state. So the startup state jumps immediately to the off state, but we make sure that we shut our shooter off. So we go into the off state and make sure that we call the shooter off. So it goes in, sets all our outputs to 0. That's what our shooter off does. And our shutdown state, our next state is always back to shutdown, but we also want to shut the shooter off when we get to shutdown state as well. Okay, let's go back to teleop, and one thing we haven't included yet is these network table variables that we talked about previously, and to be able to switch if we want to look at the table variable or if we want to use the joystick command to set our shooter speed. So we could do this two ways. One is we could make that a enum in our command. If we wanted to, we could have command, we could say set by table or say set speed by joystick, but we'd have to redo our state machine. So let's just create a bit. Let's create this bit here inside of our cluster. Bring these guys in, and if this is true in our action that says set speed, And if that's true, let's in our action where we turn our shooter on and we transfer the speed, let's put that code that decides which one of those we're going to select in here to set our shooter speed. So how do we do that? So let's go and add two cluster items. We want to add a shooter switch and a table shooter speed. Alright, so I'm going to copy this. Okay, so we've added these two variables. Let's go over here to the code and copy these. Now we're gonna this is data that's going to come in from external. So we read all our globals, our current times, and any network table variables. Those also come in here in this section. I'm going to delete this to get it out of our way. They are read here in this section so that other sections can use this data. So I'm going to unbundle by name our table shoot, and we're going to unbundle our shoot switch. I'm going to name this table shoot switch. Well, I know it comes from the network table. Alright, I'm getting a little bit crowded, so I'm going to hold down the control key and drag and just make a little bit more space for everything so it's a little easier to read. And I'm going to clean up some wires. Okay, so now we're reading the network table, shoot speed from our network table, and our shoot switch from our network table, putting them into our cluster. And now I'm going to go over here to my action, and I'm going to look at my shoot switch, just like I'm doing here in this code. And if true, I'm going to use the network table shoot speed. So I'm going to copy this, grab a select. So if my shooter switch is true, I'm going to use the table speed. And if it is false, I'm going to use the shooter's speed from my commander. Like so. So then we've duplicated this code as well into our state machine. So the point of this is sometimes you just need to add things, and it can become a big chore to add it as a state or add a new action, or so you can kind of put code in here sometimes to help you get done what you need to get done without having to reorganize your entire state machine. But if you find doing it a lot, you need to go back and reorganize your state machine and then code things if they've asked for a lot of changes, because this kind of stuff can get forgotten and start to become somewhat messy. So okay, so we have a white run arrow. That means that all the code is running, and let's test it and see if our code does what we think it should do. So first thing we need to do, I forgot to do, is to remove all the old code. I'll do that. And I'm going to replace it with my new command global. Okay, so I brought my cluster in for my commander, for my shooter, and I have a decision to make here about the three states, the three commands that I can send: shoot, enable, and disable. Right. So I need. There's no reason to shoot if my ball shooter is not enabled, and I don't have any button assigned to enable my ball shooter. But if you remember up here, I used the back button, the center pad back button, to enable my agitator. So I'm going to use the center pad start button to enable my ball shooter. Okay, so I've come off of my, remember my toggle array here, and I want to know if my center pad start button is toggled true, and my button is pressed, then I want to send a shoot command. But if my center pad start button is toggled true and I am not pressing the button, I want to enable. Okay, and if my start button toggle is not true, is false, I want to disable. My shooter speed I'm going to send from my right trigger, and remember in our shooter code we're looking at the network tables. We may use this value or we may not, depending on the shooter network table variable, or shooter switch, I believe it's called. Now we need to go to the begin code and remove this code that starts, because we've now replaced that code. We're going to keep our network tables, and I think in finish there was no other code too. So the only thing left to do is to go into our time tasks and add our loop here. Let's update the icon to say shooter loop, actuator loop. Okay, so we have actuator loop icon, and we need to go find our time tasks. So I'm going to go to project and find time tasks or periodic tasks, and we're going to add that to our other actuator loops and sensor loops. Okay, let's test our code. Let's bring up our driver station and then open our robot main and run it. Okay, so despite having my driver station open, when I try to run the robot main, I get this joystick error. And it took me a little bit to figure out what was going on here. And this error didn't show up until we moved all of the opens out of the begin VI. And then it's just saying that I'm trying to get joystick values, but my joystick value is not connected to a robot. So let me show you just briefly what the problem is. If we go to periodic tasks, and we can go into a shooter loop, or you can go into any of these loops that have a actuator or a sensor open. If we go here to the open, in any one of these, we'll go to servo open and look in here. There's this VI called simulate start engine. Start simulation engine. This needs to be running for the simulator to start up. And because all of our VIs are now in-time tasks, this start engine simulator is not in begin, and it needs to be in begin because it needs to be called first before the other VIs get called. So I'm going to take this VI and I'm going to copy it. So again, in any open, servo open, sensor open, there will be this simulator start engine. And let's just grab it, and then we're Control C, we're going to copy it. And I'm going to put this in begin. Close all these other ones. Go to my robot main, open begin, and we're going to paste the start simulator engine in the begin. And that should fix the problem. Alright, let's go to robot main and let's run it. So again, we're going to have our shooter actuator code ready to see if it's working as we expect it to. Alright, and then our robot simulator opens without problems. Expand it out here a little bit, and let's zoom in on our robot. And let's use the shift key and zoom in. Control key. We're going to do like we did before. We're going to go in and look at the boss shooter. I'm using the control and the shift keys to help me get that look. So I want to look at, again, get a look at the cross section of this and see if it goes for a half second and comes back and stays for a second. Okay, so I'm going to press my start button to hopefully start my rollers, my shooters. It doesn't look like they are spinning, so let's try and debug what's going on. Let's go here and see if we're sending the drives a value. And it looks like no, I am not. And then move this off the side so I can scroll a little bit. I'm going to go here and probe my state. See what state I'm in. I'm in the off state. So supposedly when I push the start button, take me out of the off state. So, and it is not. Alright, so that means that teleop is not sending, to get from the off state to the spin up state, I need to either send command shoot or command enable. So let's probe here. This is my global variable, and see when I push my start button. Right now I'm commanding disable. And pressing my start button is not changing it, but if I look at my driver station, looks like I am pushing a button. Hopefully that's the right one. Alright, so let's go to teleop. Go to my project and open teleop. And make sure that I'm enabled, my driver station is enabled, which it wasn't. Alright, now let's go back and see. When I push start, I'm enabled. Okay, so and my state is ready to shoot, but I'm still not sending a speed. So let's go back to teleop and see where my speed's coming, should come from here, or comes from here. So that's at 0.7 and the other one's at 0. And when I set it, that's on the shooter on is where I actually set my speed. So my shooter number 6 reads false. So I'm going to press my start button to shut off again, and my table shooter switch is false. So that means that I'm going to look at my actuator input shooter here in teleop number 4, which is 0. So until I push my right trigger, I'm not going to get any speed. So I push in my right trigger. So probe 4 is now reading what my right trigger is. Okay. So I'd like my code. I don't want to mess with my trigger right now. We'll do that another time. So I need the table shoot switch to be true so that I use my table speed from my network table. And alright, so let's do that. So I'm going to go over here to my simulator and I'm going to hit close. And close down my code. And remember the shooter switch is initialized in the begin. So let's play with our find. So I'm going to double click on shooter switch and copy, Control C, and then find, Control F, and find. Skip password protected VIs, and let's double click and go to begin, Control G, and we're going to set our shooter switch to true and save all. Alright, let's close down the begin VI. Let's go back to our main. Okay, so now let's enable robot. Now push my start button. Still nothing. Okay, so I'm getting speed here. Let's see what our shooter speed is on 1. Not getting anything. Oh, there. Now we're sending shooter speed to 0.7, which is 700 e to the minus 3, which is 0.7. So we're actually sending 0.7 to the motor, so it should be spinning. If my driver station is enabled, and it is. Alright. Well, maybe I just can't see that it's spinning. Right, if I push my green button, the animation shows that maybe that wheel is spinning. So now it shows my state is in ready to shoot. So if we go back to our state machine and look at our ready to shoot, if I send the command shoot, I should activate and move the servo, go into fire state. Alright, so that's my green button. Slide this over here so I can see my probe. So I'm looking at my state probe. I'll push my green button and it went into fire. Okay, but I did not see my servo move. Okay, so I'm ready to fire. I have a probe here saying that my wheels are spinning. The animation's not showing that, but they are spinning. I'm going to probe here on my servo angle, which shows that I'm at 85. Alright, and then I'm going to press my green button and see if the servo activates. Goes to fire, reset. I'm ready to try to fire again, and you see that my states are doing what they're supposed to, but my animation is really slow and not keeping up. It tries, but something's causing my CPU to run really fast. So I'm going to hit Control Alt Delete, and I'm going to go to Task Manager here, And I'm just going to look at my CPUs, go to performance, and you see my CPU is running at 100%. So something in my code is really running, taking up a lot of CPU cycles. So I'm going to close, I'm going to stop it, and I'm going to go investigate. Alright, so when I tried to close down the simulator, everything kind of crashed and just hung. So I had to hit Control Alt Delete and close it through the task manager, and then now we're gonna start over. I'm gonna open the project and go through my code and see if I have a loop. Usually when you're running something, your CPU runs at 100%, or you run your RoboRio runs really fast. It's usually because you don't have a loop that you're slowing down using execution timing. And I think I remember seeing one that does that. Go to Control E, go to our time tasks, and do you notice something about this loop? It has no throttle in it, no wait timer in it at all. Somehow when we were moving the code, we removed it, so this loop is running millions of times per second. So we need to put a wait timer in here, 200 milliseconds, and then save all, and that should fix our problem. Let's open our actuator loop, our shooter code. Let's probe our state. Let's probe our command. And let's zoom into our robot here. Okay, I'm going to push my start button to start my rollers. Push my start button. I'm enabled. But pushing my trigger. Looks like I'm still doing my trigger, so I gotta go fix that code. Okay, now if I push my green button, throttle up, press my green button, I'm gonna hold it. You can see it's gonna try and rapid fire. Right? If you look at my state, it says fire reset, fire reset, fire reset. It stays in the ready to shoot for a split second. So I can see that my servo isn't getting back flat. I'm going to push my back button here and get my agitator running so that my balls fall into it. So the half second seems okay, but the 1 second I need a longer return time because none of the balls can't get back into the servo. So I'm going to have to extend my my reset time, but my fire time seems to be okay. So let's close this and hope. And I set my reset time to 1. I'm going to double that, make it 2 seconds. And we're going to go back to begin. Set my shooter switch to true. So it is set to true, so I should be getting a 0.7 and not have to use my joystick. So let's debug that. Go to periodic tasks. Actually, my shooter code's right here. We're going to probe here. So you can set a probe whether the code is running or when the code's not running. So I'm going to probe these, and then I'm going to probe my shooter speed here. Let's see, what's going on. So back to robot main. Okay, I'm getting the ball to spin now. Okay, and I'm going to push my green button. Looks like it just about perfectly resets. Back takes 2 seconds to come back. And I'm going to push back to start my agitator. Alright, now I'm going to press and hold my green button. We should do some rapid fire. Boom. Boom. Now one thing you could do in real life is put a sensor there so that the actuator wouldn't fire unless there was a ball present. Alright, and then fire. Fire. Okay, so I've shot some balls out so that the agitator isn't jamming them all the time. And I just want to show you that we kind of got our return speed. Reset speed needs about 2 seconds to get the servo to come back. And I'll bring up the driver station and show you. I'm just going to press the button several times, and you'll see that it won't try to shoot until it is after it's totally been to reset mode, and it goes back into ready to shoot. Then it will wait for a rising edge, right? Or wait for the button to be pushed. Still a little bit fast. You could probably wait another half second. It doesn't matter how many times I push the button, it will only go once and return after 2. So it gives us timing and stability. Doesn't matter how fast I push the button, it goes a half second forward and 2 seconds back. And I think I would probably extend that to maybe 3 seconds because it's still got to have time for a ball to roll into the shooter. So that's it for this video. We will see at the next one where we'll start to begin to build the dashboard. Thanks for watching. Bye.